Hey guys, welcome back to my channel, and here is a new video for class 9. This question is from the chapter triangles. So first let's read the question. Okay? So there is a point O. A point O is taken inside a equilateral four-sided figure ABCD such that its distance from the angular points B and D are equal. Show that AO and CO are together formed and it forms a straight line. So let's draw a rough figure of this. There is a quadrilateral A, B, C and D. Okay, so let's take the point later. These all the four sides are equal, and the point O which will be taken will be equidistant from these two angles, from D and B. So wherever the point lies, but it will be equidistant. Right? Show that AO and CO are together formed, and they lie like it forms a straight line. So let's join AC. We need AO and CO. So wherever the O point lies, but it lies on the AC, so that it becomes AO and CO. To prove it as it is a straight line, we'll be just taking it as straight, and here let it be the point O. We will take a bit down so that we don't misunderstand it as the midpoint or the middle, as it forms a square also, rhombus also, where they bisect each other, so we don't think that it is okay, so that we don't think that they bisect each other. So let's take the point O bit down. Let's join DO and BO. As the question says, these both are equal because they say the point O is equidistant from angle B also and angle D also. Okay, so now let's draw proper figure. They haven't said that it is a square, so we are not gonna draw a square. Okay, let me erase this. Okay, here it is. Let's draw few lines a bit cross so that it doesn't feel it's a square or a rectangle. Okay, we cannot say this as a parallelogram because we don't have any proof, but it doesn't even, like, we can't even say it because of the lines we will be showing now. Square and rectangle we will be misunderstanding, but not this. Usually we don't misunderstand this. Okay, so let's take the point O over here a bit down only. Better, right? It's better. So here is O. Let's join this, and here we go. So we have the figure. Okay, let's start the solution. What they are asking for? They are asking for AO and CO. AO and CO, they are togetherly formed, which means they are formed, there is a common point of their formation, right? So and they form a straight line. When they both are joined, they form a straight line. This common point AC altogether, if we draw a line, it forms a straight line. They are asking this, right? So let's start the proof. Before that, let's write what's given. Okay, so what's given? Given is that O is a point. O is a point anywhere. They haven't mentioned where, so anywhere on AC. This AC, there is a point O. This AC, there's a point O, and they haven't mentioned where the point is, so we can take it anywhere. We cannot consider it specifically in the middle where these diagonals. We can consider these both as diagonals. If we draw this one joining B to D, this would be the diagonal. So we are not doing this. We are taking it like this. If we would draw this and the point light here, we could say, by proving this as at least a parallelogram or a square or rectangle, we could say these both bisected and this lies here, like they are straight line, like we could somewhat prove it. But here we cannot because we have taken this. So let me erase this. Okay, on AC such that OD equals OB. Okay, OD equals OB. This is given. Oh, sorry. O came on the line. Oh, let it be clear. Okay. Okay, and what else is given? Nothing. But still there is a thing, right? So it is given that AB equals BC equals CD equals DA. This is given. Right? This is given. Okay. Now let's write what to prove. To prove, what we have to prove? We have to prove that AO and CO are formed together, or you could also say we have to prove AOC is a straight line. Okay, so let's start the proof. Here is the proof. So in triangle AOD, so this is the triangle AOD, this chotu triangle, and triangle AOB, these both the chotu triangles. Forget this part. So what is left? This chotu triangle and this chotu triangle. We are taking these two. Okay. So in this, AD equals AB, which is given. AD equals AB, this is given. So let me write it full. Sometimes I would write just G to say it is given. In reasoning part I would just write G where it is understood that it is given. Okay, G means given. OA equals OA here. AD equals AB. OA equals OA, which is common. And for common I would be writing C. Let me show this. Yes, this is correct, and here I forgot to represent it like that. And OD equals OB. This is also given. G. Okay. So we have the first condition, second condition, and third condition, which satisfies which rule? Yes, SSS. So by SSS criterion, triangle AOD is congruent to triangle AOB. Right? So by CPCT, we get angle 1 equals to angle 2. So which angles are angle 1 and angle 2? Right? So we have to mention it. We will consider this as angle 1, this as angle 2. Okay? So I'll just write it in bracket, angle AOD. This symbol represents angle. Okay, so, sometimes we write this, or sometimes I will show that also. We will write like this, and then AOB. This also shows it is an angle. This also shows it is an angle. I will be using this because I'm convenient with this. Okay, done. And here, now let's come to next part. Okay, so in triangle we will be taking these two triangles now. We are done with these two. We got angle 1 equals to angle 2. Now we will be taking these two. So it is triangle DOC and triangle BOC. Right? So first condition, we will write same DO equals BO. Right? This is given. And second condition, we will write OC equals OC, which is common. And DC equals, third condition, DC equals BC, which is given by again SSS criterion. Triangle DOC is congruent to triangle BOC. I'll write CPCT here only. By CPCT, We will name this angle. I'll just erase this. Oh, this O is disturbing a lot. This has 3 and this has 4. Okay. So by CPCT, angle 3 equals to angle 4, which is angle DOC is equals to angle BOC. Right, so let me turn the page. So just for convenience, I have redrawn the figure. Okay. So we have this angle 1 equals to angle 2, angle 3 equals to angle 4. Okay. So what to do next? As we know, this is a point. Okay, this is a point. We know this, right? O is a point. So the whole 360 degree, right? If you add all the angles around O, the point O, it would be measuring 360 degree. So we will just add angle 1 plus angle 2 plus angle 3 plus angle 4, which would be measuring 360 degree. So as we know that we will be usually we know that as just WKT. This represents, we know that, right? We know that angle 1 equals to angle 2, which is proved. Okay, P for proved. And angle 3 equals to angle 4. We can substitute this in this equation, right? So it becomes angle 1 plus angle 1 plus angle 3 plus angle 3 would be 360 degree. So it becomes 2 times of angle 1 plus 2 times of angle 3 equals 360 degree. 2 we take common, and angle 1 plus angle 3 here, it would be 360 degree. Angle 1 plus angle 3 equals 360 by 2. It becomes 180 degree. Okay. So angle 1 plus angle 3 equals 180 degree. What is angle 1? Angle angle AOD plus angle COD. Angle 3 is angle COD. What is it? Angle AOD. Angle AOD plus angle COD will be angle AOC. AOC. What is AOC? It's a line. We got equals to 180 degree. Wow. Something that's 180 degrees straight. We got the result, and this is what we had to prove. Hence, proved. So for such videos, for such maths problems, do subscribe my channel, and till then, bye bye. Take care.